And the magnitude of 1 plus j omega is nothing but root of 1 square plus j omega, sorry, 1 square plus omega square t1 square. So this is nothing but the magnitude of the first term. The phase is nothing but tan inverse of omega t divided by t1 divided by 1. So it is nothing but a tan inverse of omega t1 divided omega t1. Okay. So this is the magnitude of the first term. Okay. Then we are going to calculate the magnitude of this term. This term can be written as 0 plus j omega. So its magnitude is nothing but 0 square plus omega square. So it is nothing but root of omega square and it is omega. So this is a magnitude. Okay. Now angle is nothing but tan inverse of omega by 0. Okay, omega by 0 is tan inverse of infinity. So tan inverse of infinity is nothing but 90. Okay. So angle is 90 degree. Clear? So we have calculated the angle and magnitude of the second. Now we are going to calculate for the third one. This one for the third one. This is the third one. So its magnitude is real part is 1 square, imaginary by omega t2 the whole square. Okay. Okay. Angle is tan inverse of omega t2 divided by 1. That is tan inverse of omega t2. Okay. Now we are going to calculate it for the third one. Third one is root of 1 square plus omega t3 the whole square. Okay. So its angle is this is 1 plus j omega t3. So it is of the form x plus y iy. Okay. If you're having a complex number x plus iy, its magnitude is x square plus y square. Similarly, here in the place of x is 1, so y square. In the place of y, what you are having? Omega t3. So omega t3 the whole square. So we have calculated what? We have calculated the magnitude. Now we are calculating the angle. Angle is tan inverse of y by x. So what is in the place of y? What you are having? Omega t3. So tan inverse of omega t3 divided by in the place of x you are having 1. Omega t3 by 1. So you will be getting tan inverse of omega t3. Okay. Next, so now we are going to separate the magnitude and angle. So this magnitude parts, this one, these are the magnitude parts. Magnitude part we have separated. We are writing the magnitude of g of j omega. Next, we are going to write the phase of g of j omega. Phase is nothing but we are just taking only the phase. So tan inverse of omega t1. Next, numerator over denominator. Since it is denominator, we are putting a minus. We are putting a minus. We are putting a minus. Then what is the thing you are having? 90. So 90. Then it is in denominator. So minus tan inverse of omega t2. Then minus tan inverse of omega t3. Okay. Omega t3, omega t2. Okay. So we have, this is nothing but the angle. So first we have calculated the magnitude and angle, then we have separated the expression for magnitude as well as angle. Now the magnitude of g omega can be expressed as 20 log g of j omega. So this is standard representation, that is 20 log g of j omega magnitude. So magnitude, this is the magnitude. Okay, so this is this value. So 20 log. Now we are writing this as, we are separating. First we are writing 20 log k by omega, then 1 plus omega root of omega square t square, then 1 by omega 1 by root of omega square t2 square, then 1 divided by root of omega square tt 3 square. So we have separated and we have drawn. Okay. Now log of mn is equal to log of m plus log of n. Okay, this, by this way we are writing this as 20 log k by j omega plus 20 log root of 1 plus omega t square plus 20 log 1 divided by root of omega square t square plus 20 log 1 divided by root of 1 plus omega square t3 square. So this is of the form log m into n m into n. Okay. So this multiplication of logarithm can be changed into addition. So log of m plus n format we are written. Then here this 20 log 1 divided by root of 1 plus omega square t3 square. This can be written as 20 log root of 1 plus omega square t3 square the whole to the power minus 1. But log of m to the power n is equal to n log m. So this minus will come here. So it will become minus 20 log root of 1 plus omega square t3 square. Clear? Once again I will tell. Once again I will tell. So this term you take. Two terms are similar. These two terms are similar, but first I am taking this term. Okay. So 20 log 1 divided by root of 1 plus omega square t2 square. So this can be written as 20 log root of 1 plus omega square t2 square whole power minus 1 whole power minus 1. So this is of the form log m to the power n. So this can be written as n log m. So this minus 1 will be coming here. So it will be getting 20 log root of 1 plus omega square t2 square. Okay. So we are getting this minus. This minus is coming by that way. This 1 by gone, and you're getting as log of root of 1 plus omega square t2 square, and here also minus 20 log of root of 1 plus omega square t3 square. Okay. It is clear from the above equation that when magnitude is expressed in dB, multiplication is converted into addition. So we are initially having a multiplication that we have converted into addition. Okay. So sketch the magnitude plot. A knowledge of magnitude versus the individual factor is essential. So if you want to plot the magnitude plot, then the magnitude knowledge of magnitude versus magnitude variation versus variation of individual factor is essential. So now we are going for the basic factors. The basic factors that we frequently occur in the transfer function of first a constant gain k. So second one, an integral factor k by j omega or k by j omega to the power n. So the factors which is coming, basic factors, they are occurring in the transfer function are first one constant gain k. First we are having a constant gain k. Second, an integral factor k divided by j omega. Then a derivative factor. Then a derivative factor k into j omega or k into j omega to the power n. K into j omega or k into j omega to the power n. Then first order factor in the denominator. First order factor. This is a first order factor in the denominator. Either 1 by j omega t or 1 by j omega to the power m. Then first order factor in the numerator, that is 1 plus j omega t or 1 plus j omega t to the power m. Next one is a quadratic factor in the denominator. Next one is quadratic factor, that is 1 divided by 1 plus 2 zeta into j omega divided by omega n plus j omega divided by omega n the whole square. This is nothing but the quadratic factor in the denominator. This is a quadratic factor in the denominator. Next one is quadratic factor in the numerator. First one quadratic factor in the denominator. Next one quadratic factor in the numerator. Now we are going to see some of the basic factors, their magnitude and phase. Okay. This table will clearly give an idea. Okay.